All right, so yesterday we talked about trig identities and how to, our learning target was how do we use trig identities to simplify and rewrite trig expressions. And this was the menu of identities that we came up with and we wrote down. And so we were using these identities and we were coming up with strategies to simplify these trig expressions. We were using a lot of algebra, we were factoring, and that's where we're going to pick up today. Okay, so I'm going to do this one right here. If you look at this example, again, with these types of problems, there's a lot of different types of problems. So the only way to get better at these is just to continue practicing these problems. Number 3, or example 3, says to factor cosecant squared x minus cotangent x minus 3. So this one looks a little different because if we're going to factor this, we have a cosecant squared and we have a cotangent. We have two different trig functions here. So that's the first thing we want to look at. When we factored secant squared minus 1 the other day, we factored it to secant plus 1 and secant minus 1. Down here, we have different things. We have cosecant squared and then we have cotangent. So first thing we're going to do is substitute in, we're going to use a trig identity to, which is cosecant squared x. We're going to use a trig identity to write that in terms of cotangent. So if we look at our trig identities, right here is the one that we're going to use. Right, 1 plus cotangent squared equals cosecant squared. Okay, so in this problem, okay, we're going to factor it, but before we factor it, we're going to use a trig identity so that we can write this expression with similar terms. Okay, let's use this Pythagorean identity, right, that says cosecant squared is equal to 1 plus cotangent squared. We're going to go ahead and make this substitution right here. This cosecant squared right here, and this cosecant squared right here. So this is going to equal 1 plus cotangent squared x in this case, because we're using x, and then minus cotangent x minus 3. Okay, so we make a substitution because those two things are equivalent. Now, let's rewrite this. Let's simplify our terms. We have a plus 1 here and we have a minus 3 here. So we're sort of putting this into, standard form if you're going to think of it like a quadratic type of expression. 1 minus 3 is negative 2. So I'm going to rewrite this as cotangent squared x minus cotangent x minus 2. Now we have this trinomial, and now we're going to factor this. Right? We're going to factor this in a traditional way with two parentheses. Right? We're going to say, let's see if we can break this up into parentheses times parentheses. All right? So I'm going to do this off to the side just to kind of show you a comparison. But this is similar to, cotangent x. What if we just thought of this as, x squared minus x minus 2? Think of this problem that we're factoring like this. Okay? This is pretty much the same thing that we're doing over here. Okay? But instead of an x right here, we have cotangent x. So don't let those things confuse you. We're still doing the same exact type of problem. So if you can factor this, well, you can certainly factor this. We're just using a cotangent x there instead of x. So this is a very kind of traditional factoring problem. We think about, okay, what multiplies up to x squared, and that's x and x. What multiplies up to negative 2 and adds up to negative 1. Right? What multiplies up to negative 2 adds to negative 1. Well, that's going to be a minus 2 and a plus 1. Now, of course, you could do, your x factor, snowflake method, or whatever you want, however you factor this. But it's really the same thing over here. So instead of x minus 2x plus 1, we would have cotangent of x minus 2 and cotangent of x plus 1. And there's my answer. Okay, so we're factoring this expression, okay, which we want to be good at. We want to be good at factoring. But again, these identities up here, we're using as little puzzle pieces to solve some of our problems. Okay, there are a variety of problems that we could be attacking and trying to solve. Okay, we could just be trying to simplify a question. We could be factoring if we need to. In this case, we had to factor, and we needed to use a Pythagorean identity to sort of help us out in that problem. Okay.